Welcome, everyone. Today, we are exploring a fascinating and critical challenge in building robust AI applications, long context optimization, with a laser focus on solving the lost in the middle phenomenon. Let's get started. When working with large language models, we often hit a performance wall known as the lost in the middle phenomenon. This occurs because LLMs have a tendency to pay the most attention to the beginning and the end of a prompt, completely ignoring critical facts hidden in the middle of long texts. Interestingly, this mirrors human cognitive behavior known as the serial position effect, where we generally recall the first items the primacy effect and the last items the recency effect best. So, just because an LLM has a 1 million token context window doesn't mean it reads every word equally. As we stuff more documents into the prompt, the middle becomes a massive blind spot. Look at this flowchart to visualize how LLM attention works. Our long input prompt feeds into the LLM attention mechanism. The system splits its focus. It assigns extremely high attention to the beginning, representing primacy, and the end, representing recency. However, the path flowing to the middle represents a massive drop in attention, causing any data stored there to be essentially lost or hallucinated over. Why is this a massive problem for retrieval-augmented generation? Because in a standard RG pipeline, we retrieve multiple documents and stack them sequentially. If your vector database returns 10 documents, the absolute best matches sit at the top. But think about the layout. If you pass all 10 to the model, the documents in the middle, say, documents 4, 5, and 6 are placed exactly where the LLM's attention drops to 0. This creates a severe mismatch between retrieval relevance and LLM attention. This leads to critical knowledge gaps and dangerous hallucinations because the model simply skips over the data you worked so hard to retrieve, completely wasting your context window. This diagram illustrates the RAG integration trap. The user query hits the vector DB, which proudly outputs ranked documents 1 through 5. These flow directly into the LLM prompt. However, the dotted line reveals the flaw. Because documents 3 and 4 land in the middle of the prompt string, they are completely ignored by the model's generation process. To fix this, our first strategy is context reordering. Since we know the LLM looks heavily at the edges, we must intelligently reorder our retrieved documents. Instead of passing documents sequentially by their retrieval score, 1, 2, 3, we use a reordering algorithm. This algorithm places the absolute most relevant document at the very beginning, the second most relevant document at the very end, and actively buries the least relevant documents in the center. By doing this, you are mathematically guaranteeing that your most vital facts sit exactly in the zones where the LLM's attention is inherently maximized, eliminating the blind spot problem. Observe the reordering algorithm in action. We start with ranked docs 1, 2, 3, and 4. The algorithm intercepts them, taking the highest value items, 1 and 2, and assigning them to the edges. It takes the lower value items, 3 and 4, and assigns them to the middle. The final output layout becomes 1, 3, 4, 2. The best data now brackets the noise. Our second strategy shifts from managing data to managing rules. In deep, hierarchical multi-agent systems, your core instructions can also get pushed into the middle of an ever-growing context window and be forgotten. This causes instruction drift, where the agent ignores its original goal. We solve this with a pattern called persistent instruction anchoring. By wrapping critical goals or negative constraints in semantically significant tags like critical instruction or persistent goal and programmatically ensuring these anchors are passed down the chain and placed at the very end of the prompt, we actively exploit the model's recency bias. The model reads the rule last, so it obeys the rule first. This flow contrasts two approaches. Normally, a system prompt is followed by a huge data context, which inevitably leads to instruction drift where rules are lost. However, if we take an anchored tag and inject it at the absolute end of the data payload, the LLM reads it immediately before generation, ensuring the model follows the rule perfectly. Strategy number 3 is context compression. Sometimes the most effective way to handle the middle of the prompt is to simply remove the noise. Techniques like contextual compression extract only the most highly relevant sentences from retrieved documents, actively discarding irrelevant paragraphs. More advanced approaches include long LLM lingua, which filters low entropy, redundant tokens, or autocompressors, which use summary vectors as soft prompts to compress vast amounts of text into dense representations. By compressing the text, you dramatically shrink the middle, leaving fewer places for facts to hide and sharply increasing the signal-to-noise ratio for the LLM. Look at the data reduction pipeline. We start with the bulky 10 retrieved docs. They enter the contextual compressor, which strips away the fluff, outputting only filtered sentences. These pass through long LLM lingua to remove redundant linguistic tokens, resulting in a dense, short context. The massive haystack has been reduced to just the needles. Let's deep dive into the code and see how easy this is to build. Implementing document reordering in LangChain is astonishingly straightforward. First, you perform your standard vector search to get your retrieved documents. Then, you instantiate the long context reorder utility. This built-in LangChain class automatically shuffles your document list, pushing the highest scoring chunks to the top and bottom edges of the array. Once you call the transform documents method, you take those perfectly reordered docs and feed them straight into your prompt template and chat OpenAI model chain. It is essentially one extra line of code in your RAG pipeline that yields massive performance gains. This sequence diagram maps the exact code execution. The app calls the vector DB and gets sequentially ranked documents 1 through 4. Crucially, the app routes these to the reorder utility via the transform documents function. The utility hands back the reordered array 1, 3, 4, 2. The app then sends this optimized payload to the LLM, ensuring a highly accurate answer. Let's put this into a real-time, highly impactful use case: enterprise legal contract analysis. Imagine an AI agent tasked with finding a severe penalty clause buried on page 50 of a 100-page contract. Standard RG might successfully retrieve 20 chunks, placing the penalty clause right in the middle of the prompt. The LLM loses it in the middle and falsely tells the user the contract is perfectly safe. Disaster. But by applying contextual compression to strip the legal boilerplate, using document reordering to force the penalty clause to the very end of the prompt, and anchoring the instruction to never hallucinate legal terms, the system achieves 100% accuracy. To master these advanced architectures and more, I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final architecture flow guarantees success. We take the massive 100-page contract and pass it through contextual compression. Next, we route it through the long context reorder node. Finally, we explicitly anchor the no hallucination rule at the end. These three optimization strategies converge to produce a flawless legal analysis every single time. Thank you for joining.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment. Or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.